Alright, hello everyone. Hola todos. Today is February the 7th. It's a Sunday. Let's do today's challenge. I am pretty confident that today is going to be a difficult one. Before we start, just to check, I don't see anything we need to check. Let's go for it. Shortest distance to a character. Doesn't sound very nice and easy to me. Love LeetCode. Let's take a look. Given a string, I suck at string. Manipulation of string is quite hard. Given a string and a character C that occurs in string S, return an array of integers, answer, where answer.length equals s.length, and answer I is the shortest distance from Si to the character C in S. So if I given an E, return an array of answers where the length is the same, and answer I is the shortest distance. So shortest distance is this. So 1, 2, 3. 1, 2, 1, 0, 1, 0, 0, 1, 2. This will be, well, 1, 2, 3, but 1, 2, so it's going to be 2, 1, 0. Okay. 10 to the 4th, on or on log n, or lowercase letters, C occurs at least once in S. All right. Let's give it a little bit thought. Un poco pensamiento para este. Déjame ver. So we have a letter that we know, so we can go inside and identify. We can identify the location, the indices of each individual letter. All right, each individual letter. So I know, for instance, this letter is at position 0, and this one is at position 1, and then we have E. So we have all the target letter position. So for this one, the target letter position will be 0, 1, 2, 3, 4, 6, 7, 12. So we have E. Let's just write it out. So it can be 4, 0, 1, 2, 3, 3, 5, 6, and 7, 8, 9, 10, 11, 11. So that's where the E is, right? And it will be like this. Now, given any letter, so we just say, let's talk about L, right? So L, we have 1, and we can do a binary search to determine that 1 must be inserted in front. We have to check both sides to make sure which one is closer. So 1, no, not 1, L is 0. 0 will be inserted in front of 3, so the shortest is in 3. And then if we hit another one, oh, that might just be a binary search. All right, not very confident, but we're going to try. Or we'll try about it. See how it goes. All right. All right. But I can do tests on this one for sure. No problem about that. So, shortest distance chart. So first of all, we need to. All right. I'm thinking about doing the binary search methods, but then I realized that we have to run it 2 times. It becomes I was thinking if there are easier ways. So, for instance, if we do it one by one, right? If we find one, the first one, and we haven't encountered E, we haven't encountered the letter of the target, then the distance is determined once the target is found. So every time we find it, it's going to be 0, all right? Yeah, so look at this. Look at this. Every time we found, it's a 0. And everybody else is just starting from 0 going out, starting from 0 going out. So what we can do is we find all the zeros, and we just extend from the 0 down and down. So like for here, we're going to extend down, and then we go to the next 0, extend and extend. So the next 0, extend. We need to extend. So for example, for this 0, we'll extend. All right, so it can be 1, 2, 3, 4, 0. And then from this 0, I'm going to extend back. And it's going to be 1, so it's smaller, so we replace. Smaller, replace. And if it's bigger, then we stop. Let's try this method. I feel like this method is better. I think it's better. So we're going to say res is just going to be a list, right? And then what we need to know, we need to go to once. Like we're going to go at once and find, is there a better way to find where, probably not. All right, so it's going to be minus. Let's do, yeah, let's do gigantic. Let's do a, just, no, infinite. Is that infinitivo? Right, and then for, we also need locations. C index equals this. And then for I, letter in and numerate S. If L, letter is C, res I is 0, and C index dot append I. Alright, so when you get all the positions, and then what we're going to do is for I in C index. Alright, I heard what you guys are saying. Jota. So for J in C index, so for each one of them, we're going to go both sides. So we're going to say go left, be M, M equals J, right? No, M equals J, and so we have M, and let's call it steps. So start with 0, and then we're going to say while J is larger equal to 0, and res, no, not J, we're not moving J, we're moving M. So while M larger equals 0, and res M is, so before we change, res M is larger than steps. This means we have to do J minus 1, and steps is 1. So we already go 1, right? And then we say M larger than 0, and res M is larger than steps. So the current unmodified is larger than my steps. Then we're going to say, I'll say steps. I don't like steps. Dist is better. Then we're going to say, what the hell? We're going to say res M equals dist. Keep going until we finish, and then the same algorithm, we're going to do it again. Yeah, oh, and dist plus 1, so I have to do that. And then we're going to go right. So same thing, M dist has to become plus 1. So if M is smaller than len S and res M is larger than dist, just going to do this. I think we also need to we have to decrement M as well. Okay, can we do without this? I think we can. Yes, we can. So we set m equals this, and then we say while this and while is larger than, what is distance? Distance is j minus m. And then we just say this, and then we decrement m. That will be sufficient. And we can even do it for m in range. So we're going to start from j minus 1 to 0. If res m is larger than j minus 1, j minus m, we're going to just break it. Elsewise, we assign this equals this. How many lines? 1, 2, 3, 4. 1, 2, 3. It's the same. All right, it's the same. I like the while loop. It's more expressive. So we have m, and this one is the same. We can directly just use m, and this is all the same. But instead of this is gonna be m minus j, and we do m like this. We can combine the two, that's for sure, but let's just do it this. So we check every single one and make sure that we always update when our current, oh, there's no dist, the hell, man. And make sure that our current distance is smaller, always update the smaller one, and once it's done, we can just return res. All right. Vamos a ver el test. Solo tenemos dos tests. Sí, solo dos tests. Pero es fácil en generar nuevos tests porque es no complicado. Solo tengo que crear un nuevo string y una letra. De hecho, podemos usar el mismo string, por ejemplo, love LeetCode, y podemos usar la otra letra, por ejemplo, L. ¿Cuál es el answer? Oh, Dios mío, muy largo. Con coma. No me gusta esta format. All right, what's the L? We can do L. L is going to be 0, 1, 2, 1, 0, 1, 2, 3, 4, 5, 6, 7. Pretty sure that's the thing, pero es mejor experimentar aquí. Verificar que mi respuesta es correcto. 0, sí, bueno. I'm going to change this. Shortest SC. Boom. Dios mío. ¿Cuál es eso? Alright, this is not correct. No es correcto. ¿Por qué? Okay, I got these parts right, and then it updates one that it should not update. Hold a sec. I said go left and go right. I reset M. Oh, Yeah, it's plus. There we go. There we go. All right, I am confident. Then go Fei. I've tried this one already. Probamos un otro test. T. T. No, O. O be better. Because we have two O's. Yeah, looks good. Yeah, submitting. Pending, judging. Oh, we got it. We got it. Conseguimos. Let's see the performance. It's not bad. It's not bad. We are in the majority. Well, it's not really majority. We're good. We're good. We're good. This probably is the official solution. Not 100% sure, but looks like it. Let's see. Is this an easy one? That was surprising. They gave us like an easy one for Sunday. Huh. I'm not complaining. All right, let's see. How should we summarize this? Well, it's pretty clear that the solution is we are going to first identify the indices of the letter C in the string S. And we know that in the result list, these indices will have value 0. For all the other positions, we can evaluate their values by starting from the 0 values, going to the left and right. Going to the left and right, and increment the distance along the way. We will stop when the incremented distance becomes larger than the ones already recorded in the result list. So this will run in, so we go on to take all the indices of the target, and for each target we're going to go left and right. Each one we go left and right, and that means every value will be encountered. Well, in the first part, this is going to be on, and in this part, each value is going to be encountered at most twice. At most twice. So it's going to be on, and we have run at 40 milliseconds, which is 81% ranking. We can actually directly go into the discussion and then take a look how other people treat this question. Oh, there's a solution. Likely it's an easy one. Let's see. It's an easy one. Yeah, it's an easy one. Like I said, it's an easy one. I mean, the feeling is mixed, right? If it's a medium one, I feel better. But it's an easy one, so it's like, okay, all right. All right, let's see. I uploaded. Yeah, I think that's a good question. Mean array. What is mean array? For each index, I try to find the distance of the next character. Going left and going right. The answer is the minimum of these two values. That is true. I'm going left to right. I'll remember the index 3 of the last character we've seen, and the answer is that's true. I'm going from right to left. Okay, so we just do it 2 times. I don't want to read Java. Okay, we record the C. That's fine. So then append. Good. So we got two paths, one there and one back. Once we go there, we record all the indices that belong into C, and then uh, we append this value, because we start with minus infinity. So if we haven't encountered C yet, it's going to append the maximum infinity, a positive infinity. And once we encounter 1, and everybody will be based on this one, because we're scanning from left to right. So we're going to just use the first one we encountered, and everybody will be based on that. Right? So everything on the left side of the encounter one will be like very the worst, right? But everybody on the right side might get a better treatment. And then we do the other way around, doing exactly the same thing, right? Exactly the same thing, and we pick one. Yep. Well, that's it. That's it. Okay, this is a good solution. Mine is the same. It's basically the same. I mean, there's not that much difference, but fewer lines. Consider that as an improvement. Fewer lines. Oh, Mr. Lee 215, 2 passes with explanation. Sense of DP. I don't want to read this. Nah, I think this is good enough. One solution, 2 passes. I like the original solution. Yeah, that one is pretty smart. It's a simple question, so yeah, that will be it. But I want to implement it myself. It's always a good habit, I think, to implement it yourself. You read it, you think, oh, I understand how it works. But it's always better to get it down by yourself. It's important that way. Let's see. This is the official solution. 2 passes. All right. So let's see. We're gonna have our result is going to be just a this. All right. Yeah, result is gonna be this, and then I'm gonna say C index pre-CI. Yeah, this is really smart. We do this. All right, this is really smart, very smart. And then we say for I, letter enumerate S. All right, actually, I want to make it more consistent. So for I, in range, minus be consistent. Letter is SI. I don't have to do this. And then we just say if SI is equal to C, then pre-CI equals I, and rest.append 0. Else rest.append I minus pre-CI. First path, second path for J in range. So we're going to go from minus 1, minus 1, minus 1. Same thing if SI. Hold on, do we have to update the pre-CI value? Well, I think we should. Should we? So the pre-CI we're gonna get here, right? The last one we encounter, and then we finish, and then we go the other way around, and we need to set the pre-CI. I think we need to reset this value. So we need to reset this value, right? Reset this value to. So we're gonna use this minus. Yeah, I set like this. So if this one equals C, okay, I should not use pre-CI. I just use C index. So C index will equal to J, not I, equal to J, and we don't have to append anything else. Res J equals mean res J, and it's going to be C index minus J, and then we'll return res. Let's take a look, see how this one fares. It passes. I feel I have more steps than the official solution. Let's see. Oh, you don't have to do this. Ah, that is true. All right, yeah, that's actually true. We don't have to do this because it's gonna be 0, and this is the same because it's gonna be 0 and 0 and 0, so it's fine. Yeah, and we have to say, is it the first pass? First pass. This is the second pass. Yep. First pass, second pass. Alright, I think we can just run it directly. Oh, this was much faster. So, yeah, because this is like more passes. Anyway, 2 passes. Yeah, 1 pass we can handle on the right side, another pass handle on the left side. Yeah, very brilliant. ON solution for sure, and this one we actually ran at 32 milliseconds, which is 97% ranking. All right, it's an easy question. I think this is probably a primera vez que había encontrado un problema fácil en domingo. Yeah. Never mind. That will be it. I will see you guys tomorrow. Hasta mañana. Doing